Hey guys, gonna go over a couple questions from section 6.5 and go over what the key concept was from section 6.5. What should you have taken away from all of this information? And the key concept is actually really evident in the very beginning of section 6.5, the first 12 problems where you're asked to find the average, and then, or the first, what are those, 8 problems, and then you're asked to find the midpoint or the midway point. Okay, so the questions I was asked to go over are 10, 15, 19, and 25. Those are the 4 problems I'm going to be covering today. Okay, so let's go over number 10. 10, I believe the instructions are to find find the halfway between the 2 points. Okay, so to find the halfway in between the 2 points is pretty much find the midpoint of those 2 values that you're given. And so in order to find the halfway point, we take these, you can think about it and come up with the point that's right in the middle. The difference between negative 22 and negative 34 gives you a difference of 12. So the halfway point is going to be the point that's 6 units away from both of these numbers. Okay? So the other way to do it is this. You take the 2 values and you add them up. Find the sum of them, and then you divide by 2 since we want the halfway point. So it's essentially we're finding the average. So that's the way that you find the average is you add up all the values and then divide by how many values that there are. Here there's only 2 values. Okay? So if we add up these values, we end up with a negative 34 and a negative 22 gives me a negative 56 over 2. And then when you reduce that, you end up with a negative 28, which is 6 units away from negative 22 and 6 units away from negative 34. So that's how you go about working out these problems. And this brings me to the other thing, which is the midpoint formula. And I'm going to put it in terms of 2 values because that's really what we're getting to here on number 15 and some of the other values as well. The midpoint formula ends up working out like this. You have 2 values that you are adding. You divide them by 2. Now, if you have an x and a y coordinate, then you do the exact same thing for your y values. And so this ends up being the midpoint formula, which is essentially the key takeaway from section 6.5. That's the main concept they wanted you to grasp. The other problems that are in this section are also review from what you should have already learned. But this is the big new concept of find the halfway, find the average. That's why they are asking you all that information or asking you to do all of that. Okay, so now let's go ahead and let's go over number 15. And let me just connect the lines. And so the coordinates that we have, this top coordinate is positive 6, positive 3. This bottom one is positive 6, negative 4. And then we have 10, negative 4. And they ask us to find the midway point of each section. Find the midpoint, which now we have the formula. So 1, you could either just use this formula, or 2, think about it. So if I have here this segment, which is a vertical segment, if I want the midway point, I'm just going to take into consideration my 2 y values because that's what determines my vertical element here on number 15. So if we take the 2 elements, Just double checking the coordinates for everything. So we're good. So if we find the midway point, the midpoint of it, okay, we notice that there's a difference of 7 units from top to bottom. Cut that in half, so that means I can go up 3.5 units and go down 3.5 units, and it's going to give me my midpoint. So my midpoint ends up being at 6 and negative 1/2. Now, if we find the horizontal concept of it, okay, here I'm moving from positive 6 to positive 10 in the horizontal. So if we find the midway point, it's going to be at positive 8. So you could do what we did earlier, which is just to add the two values and divide by 2. So now we have this other point here at 8, negative 4. So the other trickier one is the hypotenuse of the right triangle. And I say it's a little trickier, but not that much more, simply because we kind of already have all the information that we need. So halfway of the vertical is going to be right here at negative 1/2 for my y coordinate, and halfway between the horizontal is going to be my x coordinate here, which is at 8. So if you throw the two together, the halfway of the hypotenuse is going to be where the two intersect. And that point should be at positive 8, comma, negative 1/2. Okay? So that's essentially what you do on these, is that you take half of the horizontal, or half of the vertical, and half of the horizontal difference, and that's how you end up with the midpoint of your hypotenuse. Okay? So this was leading you to finding the midpoint of just the x-coordinate, okay? And then number 15 and those types of problems were leading you to find the midpoint of both the x and the y. I just gave you the formula though from earlier on, okay? So that takes care of 10 and 15. I'm going to move on to 19 and 25, which are a little trickier. So let's go ahead and I'm going to erase all this. Okay, cool. So now let's take a look at number 19. 19 asks us to draw parallel lines and set up some proportions. Okay, so and I'm going to try to do this as quickly as I can so that way, but if you want to fast forward through this part, I'm okay with that. That's what I would probably be doing. And let's just draw the information that we need. 1, 2, 3, 4, 5, 6, 7. Okay, so we have -2, -2, and that spacing doesn't look right, so I'm going to fix that. -2, -2, +4, -2, and then 7, -2. And then I have another coordinate right over here at +2, -2. Okay, so there's my diagram. I'm going to go ahead and connect all these dots, and then we'll label them all. These are the wrong side. Okay, So apparently that point was way off. A, B, C, D. A, B, C, D. And what they asked me was to draw a line that is parallel to BC through point A. Okay? So if we're going to draw a line that parallel lines have the same slope. So I need to figure out what the slope is here for line BC. And we see that going from this coordinate over here, which is at -2, 4, to this coordinate over here at C, which is at 7, -2. Okay, so my slope, which is rise over run, so I can see that I am going in the negative direction, and I go down 6 over 9. So essentially that gives me a slope of a -2/3. So that's what I'm going to duplicate over here. I'm going to go down 2, 1, 2, and to the right 3, 1, 2, 3. Down 2, 1, 2, to the right 3, 1, 2, 3. And I can see that it intersects line DC at this point right over here, which is 1, 2, 3, 4, -2. Okay, and that's the intersection point. So what it asked me for, let's go ahead and let's connect all the points or the parallel lines. Okay, so now I'm going to go ahead and I'm just going to label this point E. So then it asks me for all the different proportions that are made available by this. Okay, so one thing that I can say is that AD over ED is proportional to BA over CE. Okay, so it's basically they want you to use the knowledge from section 6.4 and now recreate it. So that's kind of what they were going for on this problem over here. You could also do that AD over ED is proportional now this time to the entire side lengths. So rather than the two smaller portions, I'm going to do the entire length. So AD is BD over CD. Okay? And that's kind of how you go over number 19. The key was making the two lines parallel, finding out the intersection point, and then setting up some more proportions. There are probably more proportions available than just that, but I don't want to harp on this problem too much longer. I'd like to move on to number 25. 25 is more like a puzzle, which you guys know I enjoy those problems. So other ratios, don't forget about the hypotenuse of both of these. Okay, so you could use that part of it. And now the other part, which is number 25. Let me look at my reference for this diagram. Okay, so I'm going to try to freehand this. So apologize if it's not that good in advance. Yeah, that already is curved. That's better. Okay, so we'll go with that. 42 degrees, A, 24, C, D, 8, B, E, F, 40, and then 48. And then the only other bit of information is that those two lines are parallel to one another. And they asked us to find all of the variables. Okay, so let's first focus on the angles because I think those are the easiest. So you may notice that here that we have a triangle. And so if we have 2 out of the 3 sides of the triangle, we can find the third side. So we end up setting this up. 42 plus 48 plus A is equal to 180. And if you go through the math, you end up with A is equal to 90 degrees. Okay, so A is 90, which actually makes this a right triangle. Okay, and since these two lines are parallel, let's take this into consideration as my transversal. So if this is my transversal, this is 90 degrees. That means that this angle right here is also going to be 90 degrees. And this 90-degree angle makes a linear pair. So we're going to go ahead and we're going to label that as 90 degrees as well. Okay? Let's work with E and F. So E, again, now using my 2 parallel lines and my transversal, that's 48, which means that this is going to be the corresponding angle, and that one is also going to be 48 degrees. Okay, so if that's 48 degrees, E and F are a linear pair or supplementary angles, so these two angles together have to add up to give you 180 degrees. So this is going to be 132. Okay, and now we can work on finding the other values. So for this one, we actually have to find a value that we're not asked for. Okay, and that's to find the length of this side here. Let's go ahead and we'll write that down in a different color. We're going to find, and we'll label that as X. And the reason why we need to find X is so that we can set up some of those proportions that we had on the last problem. Okay? So we need to find X in order to find B, and then B will help us solve for C. So how do we find X? Well, like I said, 90-degree angle, so this is essentially a right triangle. So we can use the Pythagorean theorem. So in order to find X, we set up our Pythagorean theorem to find it, which says that X squared plus 24 squared is equal to 40 squared. Okay? So and if you go through the process, you end up with X is equal to 32. Okay? So there's another way, rather than going through this, you could also use something called Pythagorean triples. One of the most famous triples is a 3, 4, 5 right triangle. Okay, so if you have 2 sides, one with length of 3, the other leg with a length of 4, the hypotenuse is going to be 5. And then any multiple of this will also work out. So if I actually multiply all of these values by 8, we end up with 32, 24, and 40. So I kind of knew what this value was going to be without needing to do the Pythagorean theorem, but by using the triples. Either way gives you the same answer. Okay, so now that we know this, we can set up some of our proportions. And let's work on some proportions in order to help us find for B. So we could do 40 is to 32 as B is to 8. Okay, cross multiply. So I think I said it before. I don't actually like to multiply the values just because on this next step when I divide by 32, we're going to get some stuff happening over here. So 8 will cancel out with 32 4 times, and then the 4 will cancel out with the 40 10 times. So we end up with B having a value of 10. Okay. So that's how we solve for B. C, same concept, but keeping in mind that we are using this piece of the big triangle. Okay, we can't use any proportions since it's the whole side. Okay, so we have to use whole sides. So I'm going to set it up, and I'm actually going to use this long leg and my C. And if I'm going to use C, I'm going to use this, 32, and 24. So that's going to be my proportion. 32 is to 24 as my long leg. 32 plus 8. 40 is to C. And same thing. Cross multiply. Again, I don't like to multiply them out. So we're just going to divide by 32 and then reduce our values. C is equal to, let's cancel some of this, 24 and 32 both have a, 8, 3 times, 4 times, and then focusing on 4 and 40, both have a 4 once, 10 times. Okay? So we end up with C being 10 times 3, or C is 30. And that's kind of how we find those. They're little puzzles. You guys know I like those little puzzles. I think they're fun. They challenge you. They make you use what you know, like the Pythagorean theorem, to help you find what you don't know, which were some of those other values. All right, so that's section 6.5 in a nutshell. Again, the main concept was the midpoint formula. So hopefully this was good for you guys. It's always fun doing these videos. Kind of miss the face-to-face interaction, but for now, I'll see you guys later. Bye.